Most people think the danger of sleep is simple. Sleep too little and your body pays the price. But a major 2026 study found something more complicated. Across the brain and several organs, the lowest biological aging burden was generally seen in people sleeping somewhere between roughly 6 and 8 hours per night. Below that range, biological aging markers rose. Above that range, they also rose. The pattern looked like a U. Researchers reached this conclusion by comparing sleep duration with 23 biological aging clocks built from brain and body imaging, blood proteins, and metabolites. The study included data from the UK Biobank, a health research resource containing information from approximately 500,000 adults. The result does not mean everyone should set an alarm after exactly 7 hours. It also does not prove that sleeping longer directly makes the body age faster. But it suggests that abnormal sleep duration may be connected to aging across far more of the body than scientists previously understood. The central question is no longer just how much sleep the brain needs. It is how much sleep the entire body needs to remain biologically resilient. Biological age is different from calendar age. Calendar age measures the time since birth. Biological age attempts to estimate how old an organ or molecular system appears based on its structure, function, or chemistry. Imagine two people who are both 60 years old. One person's brain scan, blood proteins, and metabolism may resemble those of an average 55-year-old. The other person's measurements may resemble those of someone closer to 67. Both have lived the same number of years. Their bodies may not have accumulated the same amount of biological change. Researchers increasingly build aging clocks to measure these differences. Some clocks analyze magnetic resonance imaging to estimate the age of organs such as the brain. Others examine proteins circulating in the blood. Another group uses metabolites, the small molecules created when the body processes nutrients, produces energy, and carries out chemical reactions. Each clock observes a different layer of biology. An imaging clock may detect changes in organ structure. A protein clock may reflect inflammation, immune activity, tissue damage, and communication between organs. A metabolite clock may capture changes in energy use, hormones, liver activity, and glucose regulation. The new study brought these systems together. The researchers analyzed the relationship between self-reported sleep duration and 23 biological age gaps across 17 organs and 3 types of biological data. 9 of the 23 clocks showed statistically significant nonlinear relationships with sleep. The organs and systems involved extended beyond the brain. Sleep duration was associated with aging patterns involving the lungs, liver, immune system, skin, endocrine system, pancreas, and fat tissue. This matters because sleep is often described as though it is mainly a brain function. You become sleepy because the brain needs rest. You dream. You consolidate memory. You wake feeling mentally restored. But sleep is a whole body state. Heart rate changes. Blood pressure falls. Hormone release follows a schedule. Immune cells shift their activity. Glucose regulation changes. Tissues repair damage. The brain clears metabolic waste through processes that become more active during sleep. Disrupting this state repeatedly may affect several organs at once. The researchers found the lowest biological aging burden at different sleep durations depending on the organ, sex, and type of clock. Across the study, the estimated minimum points ranged from approximately 6.4 to 7.8 hours. For one protein-based brain aging clock, the lowest age gap appeared near 7.8 hours in women and 7.7 hours in men. For an MRI-based brain clock, the minimum appeared closer to 6.5 hours. That difference may sound confusing. How can the same brain have two apparently different ideal sleep durations? Because the clocks are not measuring the same thing. The MRI clock observes large-scale structural features, such as regional brain volumes. The protein clock measures circulating proteins associated with brain biology, inflammation, blood vessels, immune signals, and molecular processes. Structural changes may develop slowly. Proteins can respond more quickly to stress, illness, hormones, and sleep disruption. It is like examining a house in two different ways. One inspection measures the walls, roof, and foundation. The other measures electricity use, water pressure, air quality, and signs of internal leakage. Both describe the same house. They reveal different types of problems. The broader message is not that 6.5 hours is secretly better than 7.7. It is that no single number perfectly captures the sleep requirements of every organ and every person. Most of the lowest aging estimates still fell within the general 6 to 8 hour range. The clearest risk appeared at the extremes. People reporting less than 6 hours or more than 8 hours showed greater biological aging burdens across several systems. Short sleep has several plausible ways to damage health. The sympathetic nervous system can remain more active, keeping the body closer to a stress state. Blood pressure may remain elevated for longer. Glucose control can worsen. Appetite-related hormones can change. Inflammatory signals can rise. The immune system may become less coordinated. In 2026, another study examining sleep restriction found broad changes in immune cells, including shifts involving natural killer cells, T cells, and inflammatory pathways. Separate research also found that poor sleep impaired important immune processes following influenza vaccination. These studies do not prove that every short night produces permanent immune aging. They show that insufficient sleep can change immune behavior at the cellular level. Now comes the more difficult side of the U-shaped curve. Why would people who sleep more than 8 hours show greater biological aging? One possibility is that excessive time asleep contributes to reduced activity, altered circadian timing, or fragmented sleep. But reverse causality may be more important. A person may sleep longer because an underlying condition is already affecting the body. Depression can increase time spent in bed. Sleep apnea can create long but poorly restorative sleep. Chronic inflammation, heart disease, infection, pain, neurological disease, medication effects, and early frailty can all increase fatigue. In these cases, long sleep may not be the cause of accelerated aging. It may be a warning signal. Imagine seeing firefighters near a burning building. Their presence is associated with the fire, but they did not necessarily cause it. Similarly, long sleep may appear beside disease because the body is already struggling. The Nature study acknowledged that reverse causality could not be eliminated, especially on the long sleep side of the curve. Its genetic analyses did not provide strong evidence that disease always causes abnormal sleep, but they could not completely rule out that pathway. The researchers also found that short and long sleep appeared to connect with late-life depression through different biological routes. Short sleep showed a more direct association. For long sleep, biological aging clocks appeared to explain part of the relationship. This may mean that long sleep is more likely to travel alongside broader physiological decline, although the study cannot establish one simple causal chain. The research also connected abnormal sleep duration with increased risks of disease and death. Compared with sleeping between 6 and 8 hours, both short and long sleep patterns were associated with systemic diseases beyond the brain and with all-cause mortality. These findings fit decades of population research showing U-shaped associations between sleep duration and health outcomes. However, association does not mean that forcing everyone into exactly 7 hours would prevent those outcomes. Self-reported sleep duration is imperfect. People often estimate sleep inaccurately. Time in bed is not the same as time asleep. Someone may report 8 hours while waking repeatedly throughout the night. Another person may sleep 7 uninterrupted hours and wake restored. The study did not directly measure sleep quality, sleep stages, circadian timing, insomnia, or sleep apnea for every participant. It also asked participants to include naps when estimating total sleep. 2 people reporting the same duration may therefore have completely different sleep patterns. One may sleep continuously at night. Another may sleep poorly for 5 hours and compensate with several daytime naps. Duration is only one part of healthy sleep. Regularity matters. Timing matters. Continuity matters. Whether the person feels restored matters. Symptoms during the day matter. The participants were also predominantly of European ancestry, which limits how confidently the findings can be applied to every population. Sleep patterns differ according to work schedules, culture, housing, caregiving duties, socioeconomic conditions, health, and environmental stress. The study provides a detailed population map. It does not provide a personalized sleep prescription. There is another risk in interpreting the findings. A person regularly sleeping only 5 hours may hear that one brain clock reached its lowest point near 6.5 hours and decide that their sleep is almost sufficient. That would be a mistake. Professional sleep guidance generally recommends that adults obtain at least 7 hours regularly, while recognizing that individual requirements vary. The clock minimums in the study were statistical points within a specific population, not new clinical recommendations. At the other extreme, someone who naturally sleeps 9 hours and feels healthy should not panic. Longer sleep may be appropriate during recovery from illness after accumulated sleep loss or for individuals with naturally higher sleep needs. The important question is whether the pattern is new, persistent, and accompanied by symptoms. Regularly needing much more sleep than before can be worth discussing with a clinician, especially when it appears with fatigue, memory changes, low mood, snoring, breathing pauses, morning headaches, weakness, or reduced daily function. The study's greatest value may be that it reframes sleep as a multisystem health signal. When sleep becomes abnormal, the effects may not remain inside the bedroom. The lungs may show older protein patterns. The immune system may become more inflammatory. The liver and endocrine system may show molecular signs of stress. The pancreas and fat tissue may show structural or functional aging. The brain may change at both molecular and anatomical levels. Sleep is not simply lost time between productive days. It is part of the biological coordination that keeps organs operating on the same schedule. For someone trying to improve sleep, the goal should not be to chase an exact decimal point. A more useful starting point is consistency. Go to bed and wake at reasonably stable times. Allow enough time for at least 7 hours of sleep. Keep the sleeping environment dark, quiet, and comfortable. Reduce late caffeine and heavy alcohol use. Obtain daylight and physical activity during the day. Avoid treating persistent insomnia only by spending more time in bed, because longer time in bed can sometimes make sleep more fragmented. People with chronic insomnia may benefit from cognitive behavioral therapy for insomnia rather than relying indefinitely on sleep aids. Loud snoring, choking during sleep, witnessed breathing pauses, severe daytime sleepiness, or resistant high blood pressure may justify assessment for sleep apnea. The new study does not show that improving sleep will instantly make every organ biologically younger. It does suggest that sleep duration is connected to aging signals across the body. Future trials must test whether treating short or disrupted sleep changes these clocks and, more importantly, reduces disease and preserves function. A lower biological age score is useful only if it translates into better health. Still, the pattern is difficult to ignore. Too little sleep is associated with an older body. Too much sleep can also accompany an older body. Between those extremes lies a range where several systems appear biologically younger. The number is not identical for every person or every organ. But the principle is clear. Healthy sleep is not about maximizing time unconscious. It is about giving the body enough high-quality, well-timed recovery without allowing illness, fragmentation, or circadian disruption to hide inside a long night. The clock beside your bed measures hours. The new research suggests your organs may be measuring them too.